Okay, good morning everyone. Welcome to Tech Talk on the second day of TOC Europe. My name is Paul Avery, I'm the editor of World Cargo News, and it's my pleasure to welcome you to the first of two of today's automation sessions. We have a packed session for this session. We have 5 speakers with 5 great topics, all different topics. So I'm not going to give a great overview of the industries and the state of automation because I think we need to give our time to our speakers who have prepared great presentations for us. So we're going to get straight into the content today. So our first speaker is Mariette Kokek, who is the project manager of automation for the TBA group, and she'll be talking to us about a blueprint for automation. Mariette, the floor is yours.
Okay, well, hello everyone. My name is Mariette. I work for TBA Group for the last 8 years, and I've been involved with numerous automation projects that we do in our portfolio, and also started the automation consulting that we're doing at the moment. So I'm going to take you a little bit on a journey on some of the lessons I've learned and that I hope I can tell you. So one, why would you automate? What is it actually, and how can you succeed? A little bit about our TBA group. We're about 350 people big at the moment. We have a portfolio in services and products in automation for terminals, container terminals, bulk terminals, and automated warehousing worldwide. Why would you automate? There was a very big report from McKinsey in 2018, and they were saying we would have a 20% increase in port automation in the coming years, with a prediction of 1.9 billion investments in port automation. So that's a huge market. They also predicted a lot of capability shortage, and to recommend number one recommendation to build automation capabilities in your organization. And that's actually what we see quite a lot. There's a lack of knowledge. There's a lack of people who really have in-depth knowledge on how it works. And there's a lack of organization around it, because we all like the big equipments, but we don't like the IT that we can't see. If you look at our global supply chain, I don't have to tell you about the congestion, maybe that we've seen all, and it is still here. I think there's about 30 ships waiting in front of Rotterdam here. There's a throughput growth until 2025 predicted of 15% in TEUs, and enormous labor shortage. Here in the port of Rotterdam, we have 8,000 vacancies open, just to give you an idea, and I'm guessing that a lot of other countries have the same problem. Yet, why not? Because there's a lot of people that I talk to who are always arguing against it or find it very scary, big automation. It does not bring the expected performance. It's very costly. It takes a long time, and maybe even way longer than you expected. It's complex, and that's all true. Or is it? Is it about performance? Is that all the automation, or is it also your organization, the way you've set up the project, the way you set up your operational procedures? Is it not many, many factors that look into it? And if you deep dive, there's a lot of other things that influence the performance also. Costs. It depends on what your expectation is. On average, it's about 10% of your heavy equipment costs if you do full automation. So it's still a lot cheaper than equipment, land, or civil costs, or electrification. It takes long. True. A big automation project is about 3 years, and maybe 1 year to optimize your whole operational organization. But when do you start? So if you start 1 year before rollout, yeah, then it's going to be long. So when is your start date? And the complexity is all in your hands. Do you start with a big automation project where you want to do everything at once? Or do you start as a pilot? Or do you start somewhere at the gate? Make it simple. Start, build up your capabilities, build up the knowledge, build up a good team, and go forward. So what is automation? Automation is the execution of a set of events without human intervention, or minimal intervention for semi-automation. Automation is a very deteriorated term. You can use it for just about anything, I guess. But if you look at it, there's so many things on a terminal. I'm talking about a container terminal today that you can start with. And you don't have to do it all at once. But some of our big automation projects, we see there's no IT team, no application experts at the client side, and they want to do all of this at the same time. And then they say, yeah, but you're turnkey, and expect a start button at the end, and then it should work. It doesn't work like that. I wish it would be a dream, but it doesn't, because it's still managed by a lot of people. So, do you know what you want to automate? What is your goal? What is your expectation? Can your organization handle it? And what is the expected outcome? Did you define that? Or did you just make a very beautiful marketing story? Is it measurable? How will it impact your organization? How will it impact your operation? Did you design for automation, or are you just going to say, no, I've got this manual operation and now I want to do it exactly the same with all the flexibility, but now it has to be automated. Then it's going to be super costly because it's also designed for automation. So you have to manage the expectations. No project works like you planned. No timeline is ever like you planned. So what is a realistic outcome? How can you make it measurable? How do we get from simple KPIs to real performance management? Continuously, throughout empowering your organization, continuous improvement teams, and upgrading your automation step by step, process by process. And then the business value will come, be it on on the performance, on safety, predictability, efficiency, densifying your yard, or whatever. So start small, but start. You have to think big on the biggest goals, but you have to start small until you build up those capabilities, until you build up a good team. You have to create acceptance, because what are you going to say to a terminal organization and say, we're going to automate, and you're losing your job. We've done for 20 years yard planning, vessel planning, being a strat driver, or anything like that. What do you think happens with resistance in such an organization? It's going to be huge if there's no communication about it, if you don't explain it, if it's not translated to the operational organization. So automation is really about people and processes. It's not about IT. It's not about a turnkey with a play button. It's really about how do you implement it. So how do you succeed? So I'm going to convey you some of the lessons that I've learned over the years, and hopefully you will do your advantage with it. Planning. It all starts with planning. Planning is cheap because you only need a few people and you can start very early. A clearly defined goal and outcome. What processes are you going to automate? What people are you going to involve? Do you design for automation, or don't you even look at your operation and just say, I want to automate it? What processes are there on a terminal? Because if you're just going to buy a product, give it to a terminal, and then the terminal says, yeah, but I've got like these 40 other workflows. How am I going to do that? A realistic and viable project plan. We see timelines sometimes less than a year for a project that we know will take 3 years. It's not realistic. And understand your necessary project phases and activities. If we look at the content, usually when I see a tender for automated equipment, it's about 90% about the equipment, maybe 5% about equipment control, 3% about the acceptance, and maybe 2% on integration to other systems, which is kind of one line. You need to talk to a TOC. You need to talk to an OCR system. And then they want a fixed price. Procurement always wants fixed prices. But they have no clue what the scope is. So how do we do that as a supplier? We don't have a clue either. You haven't told us your workflows. You haven't told us what kind of integrations are there. And not only that, we believe that the system is just part of it. So if you put 90% of your attention to the equipment, 5% to your operational systems, and maybe 1% to your people, we don't see it as a balance. All of this needs to be looked at to have a performing terminal. It's not about one piece of equipment which runs, it's about your whole operation which runs. I also look at the project phases. Usually a tender only looks at the first 3 phases: factory testing, installation and testing, and the individual supplier delivery with an acceptance and a handover to the client. And then it's done. Now then the hard part starts. This is often not planned or for a minimum period. And then they say, well, 3 months after acceptance, we go live. It's about, realistically, about a year later. And it's not one date. It's a period. Because you have to train your people. They have to understand it. You have to develop all your standard operating procedures. You have to get your IT and deployment team ready. It's not just the terminal operations, everything around it. So it takes another year before it really runs on full speed. And there's all kinds of ways to organize it so that not your whole terminal stops, but you can do it in one small corner. You can prepare a lot in virtualization. There's many things that you can do to ensure that this does not take a year out there, but it will take you a year to get through all of the activities in here. Success factor number 2, your tender and procurement process. A clearly defined and published scope. Do you really understand the scope you're asking from your suppliers? Does it really fit the needs? Or is it just maybe a dream that somebody wrote down? I've seen tenders that people look at, had probably written down their dreams for 2 years, but stop to forget about the whole project. And I asked her, but how do you see the project? Yeah, I don't know. I just wrote down everything I wanted the product to do, but I didn't think about the project. Okay, so how am I going to offer this? And if you look at the purchase decision, I nicked this from Gartner. It's a very convoluted process often, with a very little actually client-facing time. And very often it's with a centralized procurement and not with a terminal. So there's also a lot of differences between the actual scope on terminal and maybe what is bought by a procurement or a centralized department. What we also see, that because it is sometimes complex, I can't make it easier than that we need a lot of sense making. What is actually needed? How does it fit your needs? I'm not here to sell you something for the highest price. I'm here to sell you a success, a performing terminal. Automation has enough of a bad reputation. I think in general in the world, 55% of IT projects fail. We do quite a bit better in terminals, a lot better I would say, but still it's a challenge. So we want to help you out there. I know probably a lot of people already saw that left-hand picture, but still, this is quite often the way it goes. There's a big difference between the requested scope, the needed scope on terminal, a lot of undefined scope, things that are just not defined at all, what is offered, and then what is bought by procurement to drive the price down. If we look at an automation project, more than half of it is actually supporting the client. It's not development. It's not configuration. That's usually only 20%. Then there's about 30% custom work what we do in the product, because there's still a lot of people who want to specialize for their terminal. And then the other half is really supporting the client in all kinds of activity. IT support, networks and installation, test and QA support, setting up their own test team, deployment, go-live support, helping them with setting up operational procedures. And this is only growing. In the last years, we've seen more and more uptake of brownfield transitions. And there, the need for support is even higher than in greenfield. Success factor number 3. The things we really tend to forget. The people and the project itself. A capable project team. An IT and ops organization that need to be prepared, extended, trained, and champion what you're going to do. Your organization needs to want this, because if the ops organization is saying, I don't want this because my neighbor is going to lose his job, the other neighbor is going to lose his job. I've done yard planning for 20 years. This application is not going to take it over. We're going to fail. So you need a superhero team. And it's not a sprint, it's a marathon. Automation will take you many years, process by process, to upgrade it. You need your management support. And don't burn the team and the suppliers halfway because it didn't meet your expectations. Because you're still going to need them. It's a partnership approach. Put IT on the same level as equipment and ops. Usually it's some kind of left lag somewhere on equipment because, hey, the equipment costs 90% of the price. But in reality, you will need your IT team, and they will need to have a say in everything what happens. And it's going to be bigger and bigger. There's so many things out there on the liners, on the IoT, anything that is happening in automation, port authorities, everywhere there's more digitalization. Your ops organization, they won't know if you have this really good project team, you did everything right, the rollout is good, and then your project team. We've invested 1% in training. There's like 10 people who have been trained. But you have an ops organization of how many? 150, 200, 300 people on site. And they don't understand the way the automation or the automated processes are set up. So you need to train them. You need to trial the new operational procedures. If not, they'll make or break your success of this project. Resistance is there in many forms. Sometimes you can't even see it, but on a lot of levels there will be resistance. It's the way of people are. Change always comes with resistance. And don't be there is not just this project team or a supplier in the corner who can make it run on your terminal. The terminal has to want it. So these are my main lessons. Well, what can we do? We have an automation quick scan. We have automation consulting and a number of automation applications. I see that on the last slide it didn't work out. We're here in stand B18. I hope to talk to you, and I hope you've learned some lessons from me. Thank you for attending.
Okay, thanks, Mariette. Moving right along, we have our second presenter, who's Dennis Kogerbund from Hamburg Port Consulting, and he's going to talk about something even more threatening, perhaps, the game changer in automation, the impact of autonomous trucks and disruptive concepts on terminal automation. Dennis.
I try not to deliver on the more threatening part, Paul. Probably more encouraging is probably the word. And I also feel a bit tempted to respond to a few things that Mariette sort of said, because we obviously support a lot of people in the industry trying to look at automation in stages. However, I'll be focusing on this for now, and if time allows, we'll have a bit of a discussion later. So really sort of game changers. Why the title? What do I want to cover? I've been in the industry for 20 years, and everybody talked about automation as the big game changer for the next period. Now, 20 years on, if I look at the global terminal landscape, I'm not sure about you, but the percentage of terminals with a significant level of automation is not significant. And that's for various reasons. And I want to go through a few sort of changes, technologies, and otherwise that we're seeing happening in the industry and how it might change how we look at automation, how it may ease some of the automation implementations. So I'm afraid not too much to scare people away, hopefully, but let's get right into it. Why am I here? What do I sort of talk about very briefly? We try to make sense of terminal operation concepts for clients moving forward, be it automated or not, build a business case, because especially when we talk about automation, people are very focused on, we'll be cutting costs, and we'll be very performant. If you do a staged implementation, mind you have, and Mariette said it, you have a very long project in preparation and implementation, and the ultimate financial benefits don't kick in overnight. So we obviously look at the financials there as well, and in case of brownfield, obviously make sure that operations continue, because that's what pays for the project as we go along. So automation as we know it, I'll probably have those two sort of running. I'll quite happily be showing CTA. That's sort of how I started my career, and then something which is even considered very, very automated on the right-hand side, which is VICT. They've been in operation for a few years, and significant advancements in terms of technology above and beyond that really hasn't happened. So we're looking at concepts 20 years and older that we consider still being state-of-the-art. Now, I tend to make reference to these here. Who's having a 20-year-old cell phone? So we don't necessarily have come a sort of very long way, and I guess what I will try to go through is some of the changes happening now, how it may enable more automation being implemented moving forward. So full automation, as we think about it, quite often perpendicular yard setup. Why? We need to separate manual and automated traffic. Now, I'm a logistician. We're using a multi-million-dollar crane to execute a part of the horizontal transport, just because we have a perpendicular setup. So also we need circulation areas twice. So there's a few components where, despite the fact some of the automated solutions give us more capacity, not necessarily we extract all the value from those technologies that we could. Now, 3 areas, only one of which I'll be going into much further detail, because otherwise the remaining presenters won't have any minute in this session. I'll be talking a bit about autonomous trucks. What I will leave out but still want to mention here are, all the digital solutions. There is a lot in process automation. Automation, people always think about equipment, as Mariette rightly said. Everybody's thinking about automation as a big crane. There are lots of things you can do in process automation which actually allows you to ease and optimize your processes, not only make it better, but also more reliable and ultimately also cheaper, through which you can start the journey. Box Bay and similar systems, I should say, I'll just briefly mention here because the last presentation is all about that. So I probably don't want to go into that hot water of telling something which is not 100% accurate. So really autonomous trucks. Why is it a major change? First of all, no traffic area separation. You're sharing the same road. Immediately, you're saving space, right? Secondly, realignment of terminal components. One of the areas which has held back automation, especially in brownfields, is you're ripping all the terminal apart and you're starting to build in different sizes of chunks to convert a terminal. Now that is massively disruptive, and that comes with a significant risk. Now, in the alignment, and that's really what this is all about. When you can share roads for internal and external traffic, when you run an RTG terminal, now apparently it becomes much easier to implement staged automation as opposed to you go from an RTG terminal to an ASC terminal, which changes all the layouts. It becomes more compact, which is obviously immediately linked to the first component. And with that, the retrofit of established terminals, especially where they have a parallel layout, becomes much, much easier, also because you can do it in smaller chunks. And also, again, reference to something Mariette said previously, you can much more easily do it in stages. Now, design implications I spoke about. All of what you see on the left-hand side, all the terminals, they are what we would consider sort of, fairly modern, somewhat sort of automated ASC terminals mostly. You'll note that parallel ASC systems we mostly have in Asia, some in North Africa, and so on. If you look to the bottom right, and that's really interesting because I well remember the first studies we did for Khalifa Port. The first stages of the port, they're all perpendicular, and we had a massive discussion around transshipment rates and how perpendicular setups can actually respond to high transshipment rates, because obviously the cranes are bound to either the hinterland or the waterside. Now, as you see, as they expand, some change has happened. So they're going parallel all of a sudden. Now, they continue to have a high transshipment rate. They are not fully automated in the first stage, so whilst they have allowed for separation of hinterland and waterside operation in the first stage, they haven't necessarily, on the basis of the current technology as the expansion happened, but this layout on the bottom right now and moving forward will allow for full automation in the future. Now, one cautionary word, technology evolution is always faster than authority approvals. So looking at risk management, always be aware of, no matter how brilliant your technology that you think about might be and how well it functions, it will have to pass authority approval processes. You cannot start early enough doing that, right? One other thing, and it's a bit of a sketchy setup, and I can't believe I'm still saying that after 20 years, because everybody said automation is really going to kick off by the time it's plug and play. We're not there. I don't believe in a very well-functioning automated terminal that differentiates itself from the competitors. We will ever be in a setup where it's just plug and play. But the one thing, and that really speaks to one of Merit's points, if we don't get a good standard of a standardized application programming interface through which we truly implement modularized automation, we will continue to have significant, cumbersome automation implementation projects, which are then very long, they take a lot of time, etc., etc. So whilst I agree with you need to prepare your organization to make sure people understand and drive automation, there are a few technology, base components that still need to be sorted out. There are a few good initiatives in the industry, obviously, but this has to happen. And we should be learning from other industries here, by the way, because we seem to be the only ones who are very focused on ourselves, but there's a lot of other industries where automation has happened massively over the last decades. Just think of car manufacturing, right? Now, really want to be quick. Key takeaways. The automation solutions change. Parallel layout may very well become, the more preferred sort of layout of the future, just because it also allows, as the second point says, for automation for terminals that are up and running. We have seen a lot of projects where before they went into any implementation stage, they had been canned, stopped, just because people felt it would be too cumbersome to implement. Now, some of the solutions, just because you allow autonomous trucks to, for example, to interfere with RTGs and external trucks and all the rest of it, it may very well become viable in a staged implementation. It's much easier to implement as opposed to converting entirely to the established setups for terminals that have thus far discarded it. So there's far less risk in my mind to do this. So every one of you has thought about it, not done it for good reasons in the past. You may want to have a think about, subject to, again, consider authority approvals that may not be in place yet. Now, testing, integration, implementation. I see you're nodding, right? The importance of this remains, or the fact that this is crucially important, that still remains valid. You got to be on top of how to implement automation. And on the basis of tenders, for example, be it for equipment or for systems, we very strongly recommend to have a very, very good view of current processes, future processes. How are the processes going to be in the interim as you transition? If you have that as a component to your tender and full visibility of transparency, apparently whomever you ask to deliver you a system or a crane actually knows what the scope is. It may feel like a little bit of extra work to start with. To be honest, the best thing that can happen to your vendor is you've signed a contract but left out a few things you may be needing later. So in terms of risk management and budget conformity, be very precise about what you want to ask for and what you have to ask for. Don't necessarily ask for the gold-plated solution because that comes at a cost, but be very specific before you start putting money on the table, signing contracts, what you want. Business process modeling is a key component of that, and on the back of this, identifying which interfaces for as long as we don't have standardized sort of interfaces to run this. Now, all the detailed planning all along the way remains valid. Also, if for whatever reason somebody suggests a design departure from what you had planned, test it, try it. If you need to, please simulate it to understand the impact before you sign it. and all those components. Now, lastly, and I said it several times, the open API strategy will drive or should drive automation modularity. So in a perfect world, here are your 20 options. Have an API strategy in place that allows you to select for your terminal. It's module 3, 7, 9, and 11 that I want. Make it easy to implement. Now, it will not be plug and play still. That's the one key thing I really think is important. You still need to have the team to plan it, implement it, improve it. And the more capability you develop in-house, and that's what we often see, and the budget tends to be forgotten as a project cost, the more knowledge you have and develop in-house, the more you're able to own the project. And as you own the project, you understand how the operation is going to be moving forward. As you understand that, you can drive efficiency on your own and take that from a consultant. That's good for you because the bills from the consultant will shrink over time, which obviously improves the business case. So those are my 4 key takeaways. With that, thank you very much. And obviously, I'll be happy to answer any questions as they arise. Thank you.
Okay, great. Well, that brings us now nicely to the cranes. So someone from Finland, I think. Tero Jakala, who's from Kona Cranes, a product manager from ASC Systems, who's going to talk to us about shortening equipment ROI at automated container terminals. Tero.
Yeah, thanks, Paul. Hey, good morning on my behalf as well. I have to say that it's great to be here after all the long years of COVID restrictions. Title of my today's presentation is rather long. Shortening equipment return on investment in automated container handling yards with cutting-edge technology. I have to thank our marketing department for the nice title. I see some of you here who are familiar with yard crane automation, but I also see a lot of people here who most likely don't have that much in-depth knowledge about the crane automation at the yards yet. The automation trend is picking up with a fast beat for sure, and there are a lot of container terminals in the world which are planning to automate their RTGs or RMGs, some with the smaller steps according so-called automation growth path, and then some with some bigger leaps. What I've noticed, however, that not all container terminals does have that in-depth knowledge about the automation yet, and therefore what I've recognized during the years that there is a lot of questions related to just the main metrics of automated yards, that how the automation affects to the or reduces the operational expenses, and how that reflects then to the initial investment to the automation. So now I try to answer in a simple way what are the main metrics, and also how even small improvements or differences really make a huge impact from return on investment point of view. So let's take an example and look at the end feed type of ASC yard, and to be more specific, let's focus on automated road truck handling at ASC yards. So for those of you who don't know it yet, what the automated truck handling means, that the cranes position the crane to the road truck or picks the container from the road truck in fully automated manner without any manual intervention. It's not a new technology as such. It's in use in several terminals in the world already today, so I would consider it as a quite mature technology. But as technology is evolving all the time, there is for sure room for improvement, and actually the players in the market are doing just that. The improvements might be a bit smaller than in the beginning, but nevertheless. So what are then the main metrics or KPIs to look from return on investment point of view? Let's put it in a more I would say, or a bit different or more clear context, and let's use an equation called overall equipment efficiency, which was introduced by Mr. Seiji Nakayama already back in the 60s. So the equation is coming from, or result is coming from three factors, or multipliers: the performance, quality, and uptime. Now, if we use the terms which we are more familiar with, it would be productivity, meaning moves per hour, success rate of automation, so how many moves the crane is able to do in a fully automated manner versus that how many moves need manual intervention by a crane operator. And then, of course, the availability, which is then the how much the crane is available to do its job when you deduct the planned maintenance hours and then potential breakdown times out of it. So that's it, three factors or KPIs, quite simple stuff. And then when you look at it and also it's quite logical that those metrics are exactly the same in a higher level as they would be in a manually operated terminal. And these are also often or pretty much always KPIs in commitment, like contractual commitments between the system suppliers and the terminal operators. In one way or another, the definitions might vary a bit. So let's look at those factors one by one. Let's start with the productivity. So when thinking the productivity of the crane, it's basically cycles, how many cycles the crane can do in an hour. And in order to improve that or making improvements on that, there is of course basic driving parameters like crane speed and accelerations and such. But in the market today, I don't see much, or at least very big improvements coming from there. There is certain limitations already in ASC cranes that when you see the market, all the players have got pretty much the same speeds and driving parameters. From productivity point of view, there is also the external reasons which are not related to the crane productivity as such as waiting for the truck drivers, waiting for the remote operators as such. But where there is really room for improvement is the combination of load control system and the scanning efficiency. So the last step of the cycle when the container is put automatically on the road truck. So by load control system, I mean that how well the crane and the system controls the sway and making the final moves and micro moves when the container is positioned. And then there is the scanning efficiency of the sensors, that how well they can detect the exact position for a container on the road truck before lowering the container. We at Konecranes don't have naturally the exact measurements from all the container yards with such technology in the world, but we have seen and we have received feedback about from the different terminals, and what we have seen that in that final step when the container is first scanned the position where to put the container and then lowering the container to the truck, there is a difference between the systems of easily 5 to 15 seconds. Now, if we make a just very simplified calculation and we use, to be on the safe side, we use that if we could improve the reduce the load cycle by 6 seconds, it would mean actually in the productivity point of view, 3%. 3% more moves per hour annually. So again, easily then you can calculate the monetary impact of that by knowing how many trucks you handle and naturally the charges you are getting from the trucking companies. Now, next factor is then the success rate. So again, meaning that how well the automation system is able to position the container to the truck versus then that how many times it's not successful and crane operator is needed to do that remotely. Again, same systems there are required. The load control system and the scanning sensor system are there at the core. When we are looking again what we have seen in the terminals and the feedback we have received from remote terminal operators, there the success rate of putting the container automatically to the truck, success rate varies between 70 to 90+%. If we now take again very simplified example and think that if we would improve the success rate by 13%, going from 75% to 88%, that would actually mean more than 50% less exception handling, meaning more than 50% less crane operators needed. And that then means if we take a relatively large ASC fleet of 40 blocks, meaning 40 landside cranes, that would actually mean 2 to 3 crane operators less per work shift. Again, you can then calculate yourself the monetary impact of that from return on investment point of view. Then the last factor, the availability, and when thinking from the positioning system point of view, I would differentiate two areas. So there is the maintenance, so how much maintenance the system requires. So, and then there is how many sensors there is, how frequently they need a cleaning, how easy it's to do the cleaning. Can you do it from the platform and the crane, or do you need a man lift or so? All will have an impact on the shutdown time. But also what should be paid a lot of attention more than perhaps today is the need for calibration. So what we have seen in the field that there is really some systems doesn't require any calibration, so they are automatically calibrating themselves. Some need certain level of recalibration during the year. Then again, taking an example, not the values, extreme values, but something in the beginning, between what we have experienced is that if there is 18 hours of recalibration required during the year, that would actually mean in a fleet again with 40 ASCs, that would mean lost moves per hour more than 12,000 moves. Again, easy to calculate the monetary impact of that. Of course, it's not that simple. Some of the calibration can be done during the regular maintenance period, so therefore then it doesn't directly affect to the downtime or increasing the downtime, but on the other hand, in that case, it will increase the maintenance labor costs. So, as a summary, putting all those together and then looking at the pie chart over there, and these three metrics in OEE from return on investment point of view, it really makes sense to focus on the productivity. As ASCs are process equipment running more or less 24/7, even a slight increase, like 6 seconds in the example, makes a huge monetary impact in the end and directly then impacts the return on investment calculation. However, do not forget the uptime either. So there is really, as seen, if the crane is down for maintenance, there is 0 moves per hour. So really, and there is differences there and improvement points which should be pinpointed when the solutions are looked at more carefully. There is also certain meaning on success rates in return on investment, but not as huge perhaps than with the others, but the success rate then have certain other benefits outside the ROI that should be more taken into account. So to sum up, focus on uptime and productivity, and also small differences make a huge monetary impact. So, thanks all.
That leads us nicely into the next presentation, which takes a look at what was mentioned briefly there, is that the remote or teleoperation of automated cranes and the job that involves. And bringing us to that is going to be Ilse Housing, who's the director from Ops Factor. She's going to be talking to us about remote or teleoperation at automated port operations.
Thank you, Paul. Yeah, I would like to talk a little bit more about the human factors in automated projects, a subject that seems to be forgotten because there is still a human factor there, and I would like to explain a little bit more about that. First, I'm the director of Ops Factor. I'm specialized in human factors engineering and control room design. And Ops Factor is an expertise center of control rooms and remote control room solutions. And we are a part of the Metago group, and we are a spin-off of the previously known Merford Cabins. I would like to start with some pitfalls of automation projects I've experienced in my career. And then I would like to give you some more background information about human and system performance and how that relates to terminal operation. And that will bring me to the differences of remote control versus teleoperation and the impact that will have on the requirements of workplaces and work environment in your control room. I would like to wrap up with some inspiration for you if you are implementing or working on automation projects right now. Although there are many pitfalls, these 3 pitfalls are recognizable and often experienced in technical and cost-driven automation projects. Let me start with conservative innovation. What I often see is that manual operated technology and related task allocation are the starting point of automation and innovation. What this means is that technical and organizational constraints of the manual operated system becomes the starting point of your new design. Remote control workstations are often designed around a crane cabin, for example. But why should you putting a cabin design into an office? Cabins are designed around the limited space available on a crane, with critical lines of sight, because there are no cameras used to operate. It's a bit like eating soup with a fork. The second pitfall I would like to address is the leftover principle in automation. The leftover principle is based on a thought that you let the machine do whatever it can do and then let people do whatever is left over. This is basically the consequence of conservative innovation. But if you do so, you make an unrealistic assumption about the ability of people to monitor and effectively intervene in any system where there is little for them to do over sustained periods. The third one I would like to mention is the misleading assumption that automation removes the human role in the system. It's a misconception that automation will remove the human role in the system. Automation nearly always changes rather than removes the role of people in the system. Take, for example, the transition that is made in the counters of supermarkets and train stations. When the Dutch railway company introduced the ticket machine, they thought that they could remove all counters and desks and all personnel. But they forgot that travelers have different questions than only buying a ticket. Some of them need help to have questions about delays or complex train tables, or they need other information. And sorry about that. The counter personnel could be reduced, but some came back in another role, and as you can see on the picture, in a rather clumsy loft. And this is just the tip of the iceberg, because they also need to hire more and specialized IT personnel to solve IT-related problems of the newly designed ticket purchasing system. So recognize that automation nearly always changes rather than removes the role of the people in the system, and those changes are often unintended and unanticipated. They can make the tasks people need to perform more difficult and can disrupt established relationship lines of communication and the ability to exert authority. If you acknowledge the human role in the automated system, you can analyze and address the impact early in the design process, starting with a proper task allocation and impact analysis of the complete system and not only the equipment you are going to automate. Sorry, this is the one. So let me share a little bit of human factors background information about task allocation. This overview comes from a well-known article, and it shows the level of automation can be applied to 4 classes of function that map generally to a simple 4-stage model of how the human brain processes information. It's about the information acquisition, information analysis, decision and action selection, and action implementation. I have tried to fill this in for the 3 levels of automation we currently see on the terminals: the manual operation, the remote operation of semi-automated equipment like the ship-to-shore cranes, where you have 1 operator per machine, and the operation of automated stacking cranes, for example, where 1 operator monitors where 1 operator monitors multiple equipment, and especially by exception handling. To give you an indication on the score, low is entirely human, no automated support, and high is fully automated, performed with no human support. Of course, we can probably debate about the details, but the trend becomes clear that decision selection and action implementation is still a human role, where the system supports the human with information acquisition and data analysis. The following 4 cornerstones are important to address in your proof of concept of automation when you do the task analysis. What is addressed to the system and what will be addressed to the operator? It's about the ability, having the means and resources to execute control. It's about authority. What's the actor, either people or technology, is or is not allowed to do? The control, who is having the control, acting on the situation so it develops in a preferred way. And it's about responsibility, being accountable for the consequence of control. If you put that together, then you will understand that the operator role is still needed. This diagram shows how the authority of control and the ability to detect and respond to the unexpected events work out for the operator, where the resilience gulf indicates the amount of human support that is needed to respond to the unexpected events. And the authority gulf indicates the level of human authority that's still needed to exert control within the system boundaries. In manual operation, the crane driver is maximum in control and is authorized to act based on his experience and his skills. In remote operation of ships-to-shore cranes, you see that the system is gaining some authority to exert control, but the system still relies for most parts on the human ability to detect and respond on the unexpected events. This brings me to the difference I see between remote control and teleoperation and the transition we are going through. Remote control operation is not more than operating equipment from a distance. Whether it's a one-to-one operation of an STS crane or 1 operator operating multiple stacking cranes, the remote operator operates 1 piece of equipment, either continuously or by exception. Teleoperation, on the other hand, is the umbrella that encompasses controlling, monitoring, and remote operation of a fleet. And with the increasing level of automation, there will be new jobs arising, like, for example, automation and maintenance support, process control operators, supervisors, and IT specialists. But different operating concepts require different workstations and different control room layouts. For the remote operation concept, each equipment type is having their own workstation. Switching between vehicles is needed. Each equipment type is having their own interface, and operators will be working more in small dedicated teams or solo like they were used to do in the crane. In case of teleoperation, you might want to have a multifunctional desk that can be used for the operation of different types of equipment. In that case, we need to look into the possibility to drive a semi-automated vehicle with joysticks, maybe, or to operate highly autonomous cranes with keyboards and mouse. In the teleoperation concept, teamwork and communication becomes more important, and that should be reflected in your office layout. That brings me to the success factor for automation projects and ensuring the human factor's role within automation projects. Acknowledge the fact that there will be humans in the loop and that new roles implicate new teams and changing workflows. This requires different workplaces and other control room layouts. That's why early alignment of operations and project teams is so important. And this is the fundament of a human-centered design approach. Successful automation starts with the right design. Thank you.
Okay, our last presentation is a case study about Box Bay, the innovative system in Dubai. And I'd like to invite Dr. Matthias Stubner and Ronald van der Meer from DP World and Box Bay to come up and tell us about what they're doing in Dubai, please.
It is good to be back over here. I like for 3 years ago, I also gave a presentation about Box Bay. Also people sitting in the room, the majority was a little bit skeptic. Will it really take place? And the truth is, it really took place. And I will go further with my the plus to give me the next slide, I think. No, this one, yes. So this is really what we have built in Jebel Ali. It's there. It is a high bay store with a dimension of 26 meters. It's 11 high. We have 2 stacker cranes. It runs smoothly. We have an underground conveyor system which connects our truck crane where we can handle the trucks. We have the water side connected with the straddle carrier. So, and of course, it's all fully controlled with the warehouse management system. I will tell you more in detail how it is running in the next movie. This is really how it works. I can show it a little bit slower, but okay, this is how it runs. First of all, Box Bay. Box Bay is a joint venture between the SMS Group and Deep World. We are running smoothly. Over here you can see, of course, our standard terminal where we do the containers. Containers can be brought to our high bay store both by truck or by straddle carrier. In this movie you will see it going by a truck first. This is where it is. The Box Bay is there. You see at the right side, you see Terminal 4. The truck can drive and pass through. It's a direct access. He doesn't have to reverse. The only communication with the truck takes place with a truck alignment system. So he knows where to drive. He stops in the right spot. Then the automatic system will start. After the job is done, green arrows will indicate to him that it is safe to drive away. So there is no interaction with the driver itself. Safety is taking place because we detect the cabin detection and we have also an anti-lifting device. After that, the containers will be placed on a pallet system which can go in the building. In this design where we have Jebel Ali small, we have only 1 truck crane. In the final design you should always go for 2 truck cranes. 1 truck crane takes care of containers loading and the other one for offloading. The reason why we're doing is we want pallets to go out of the building fully loaded, but also going in the building fully loaded to increase our system. That underground system stops and the crane will pick up. Shortly going back to the truck crane, we easily run over there more than 30 moves an hour. We have done testing for 9 hours where we do between the 32 and 35 moves an hour. The stacker crane, which is running in the aisle, it picks up the container from the pallet and it can move in the aisle. You can see over here. The stacker crane has the possibility to place at the left side or on the right side. So every stacker crane has on 2 sides the possibility to store containers. Containers are stored in the gray rack structure, and the nice thing about the rack is there is no movable part in it. There is a lot of other designs in the market where everybody is nervous about maintenance. This rack structure, you don't need any maintenance. There are no movable parts. And of course, there's always the discussion about inspection, about cracks and stuff like that. You should take into account every location when you store for 5 days the container is used only 70 times a year. So after 30 years of uses, it's only used for 2,100 times. There is no fatigue. There is no concern about that one. Here you can see the simplicity of the rack, very easy. Containers can be packed up and go out on the water side, and they will be placed on the table. We have run tests over there, and when we can run easily with one stacker crane, 20 moves on the water side. So at the land side, we can run 30 with the crane, and on the water side, we can easily do the same with 20 moves with the stacker crane, with the carrier picking it up. And then the carrier will transport that move to the water side, a key crane, and place it on the ground over there. The whole erection started in the summer of 2019. We were ready in 21. At the end of 2020, after 1.5 years, and the whole year 21 we used for testing. The first half year we were running all functionality, exception handling, all those things, performance testing. And the second half of the year we did all kinds of testing about reliability in relating to maintainability. So some sensors we have replaced, and that's what we have done to make it more reliable, easy to maintain. I will continue. Let's go there. When everything is okay, the next slide will come. Why do we like box bay as for our side? It is safe, it's fully automated, no people has to go inside. It is a smaller footprint. It's environmental friendly, it is energy-wise. We have for sure a lower energy consumption than other mills, low OPEX. Now, it works with all kinds of horizontal transport, but the most of all is that you reduce your land uses and you have no unproductive moves. That are the two big benefits what you have. I will go to the final slide for me, and this is this one. The whole story for Deeper World started with the fact that we want to do a study, is storing in the rack the right way forward, yes or no? And the reason why is that we have now a system what is by far more effective. We can do more moves, we can store more containers in the same footprint, and also you can have, of course, a much higher volume, significantly higher 3.4. So what you see, we have now a system in place which is operational-wise cheaper, but I know everybody in the room is saying, yeah, but it's very expensive, you have to build a steel structure. That's fully true. So there is a saving in the OPEX, maybe not enough for the whole CAPEX. But if you also have the possibility to, on the brownfield terminal, by switching from a yard constraint with the box bay, your yard is no longer constrained, you have additional revenue. The additional revenue easily compensate the additional CAPEX. And for sure, this is taking place when you're looking for a greenfield terminal. Greenfield terminals are always a lot of reclaimed land, or you have to break down a mountain to create your terminal. All those costs to get the reclaimed land, it can easily, because you need a smaller footprint, compensate the additional CAPEX. So we, from our perspective, from Deeper World, are really happy with this product. I give the word to Matthias.
Thank you very much, Ronald. And I will continue with the next slide. Yeah, Ronald said it. The big advantage of box bay and the major selling argument is the high densification effect. He showed in the last diagrams. But that is also a sustainability argument, because that it's most worthwhile thing what we have is our land close to the ports, and you can see here on this picture how much we can save on land. Then there are other sustainability and environmental aspects. Of course, the system is fully electrified. Many other systems are as well. But here we store the containers much more in the height instead of the length. And the energy recuperation works better with getting from the potential energy back into the net instead of just, let's say, going forward and backward and taking advantage of your braking energy, getting back into the network. Then, of course, it's clear with all other electrical systems, you will have no local CO2. And if you use green energy, you will have zero CO2. I come to that aspect later. Noise suppressed operation and lack of light pollution is clear. It's a building, it's not emitting light and noise, but it's also blocking light and noise from the key wall back to the areas behind in the hinterland. Then let's look at that example here, the lower example. I tried my very best to pick a good, let's say, example from Singapore. You can clad it with, I would say, mimicry clads or also with green walls to make it nice. It could be a landmark in your container terminal. And with the last point, I would come to the very interesting, let's say, feature of this design. You can use the roof for a photovoltaics energy plant. So we did some calculations, and with these calculations we found out that it's easy. We know from our test operations how much kilowatt hours we need per move. It's about 2 kilowatt hours per move. That's already low. We don't need to multiply that with shuffle moves and so on, because the containers are in direct access. But you see from the diagram our findings according to where you have the terminal. It might be the harvesting of energy is different in the world, that even in Antwerp, the system, when it's cladded with the roof, the photovoltaics roof, you get 95% more energy than you actually need. In other areas, for example, New York or Long Beach, the factor is much higher, and the question is, what are you going to do with that? You can pump it into your, I would say, over the day into a reefer cooling mechanism, switching off the reefers overnight. You could feed it into the grid to compensate other operations. You could store the energy, or you could produce something else, alternative fuels with hydrolyzers, for example, and so on. So at the end, what we found out, you can make with a system like that, cladded with a photovoltaics roof, according to the effectivity of these roofs today, and a big area which you can use twice, you complete operation not only CO2 neutral, but also CO2 positive, which is, let's say, an outstanding effect, I think. Then, as we have shown the system 3 years ago for the first time, we have now developed it so far that we have a modular, I would say, toolbox. Basically, we have two main configurations. The first configuration is the side grid. We call it the side grid. You see in the upper picture. That is what you have seen in the video shown by Ronald, where the interfacing to the water side is taking place at the sides, on both sides, with interface areas. And then we have a so-called top grid configuration, where the whole building is lifted up by a story so that you can drive under the building with your waterside traffic. For example, AGVs or terminal trucks, they will go under the stacking cranes in these Ls to be loaded directly from the top, which is a big simplification, of course. And depending on where you are and what you have already in your container terminal and what you plan for your operational concept, you have different possibilities here. The next slide leads me a little bit to what do we from Boxbay believe where we will see our market. And we see, of course, at the beginning we saw a big market with greenfield applications. This is a picture from a study which we did for an investor group in Canada, in northeast Canada. You see that is the so-called Crémaillère Bay, a natural harbor, as you have really a perfect bay for building a port. The only point is there you have deep water and the mountains are relatively steep. You see locations like that in many areas in the world. Here could be also a city or an infrastructure area or traffic or whatever. Container terminals are tending today not having any more land to grow. It's clear when you have land for free, it would not make sense to go an investment like a highway store. But if that is a seldom situation, and very often you have exactly the contrary, you don't have any more room. And in some areas in the world where the necessity for container terminal is, you cannot, let's say, go hundreds of kilometers away from, let's say, where the traffic is. You need to put a container terminal there, and that with a highway store. And this example shows quite good how small the footprint is and what you can do here. As we progressed with our project, we found out, because especially when in the last year, when we showed the system at the expo, in the nice pavilion of DP World and also in Jebel Ali, there were many people with brownfield application requests. And that is exactly where I personally believe today our biggest success will be here. Because there are already a lot of container terminals in the world. Many of them are standing, we say in German, with the back to the wall. They have no more room to enlarge the container terminal. There might be deep water or mountains or traffic or infrastructure or, I don't know, urbanization grown into close to the container terminal. The container terminal has grown by itself. And here is, of course, the possibility to stepwise fade in a new operational concept. It's clear you cannot close down a container terminal and 3 years later you open it up with another operational concept. You need to find a solution how to stepwise retrofit it. And how that can be done is shown for this case study in my last slide or movie. You see here such a container terminal in such an environment, mountains, deep water, already a crowded operation with RTGs, 7 white here in this case. Industrial plant on one side, you cannot go further and what to do. And then, of course, the trick is to empty out an area where you have to take it out of operation. The trick is not to make that too small, that the effect is big enough later, but we should also not make this area too large that it disturbs your operation too much. In the first phase, you have to take the containers away and start with your construction. And of course, it should be done in that way that parallel the container terminal operation takes still place. Of course, you will have in the first phase some disturbances, but if the high bay store is big enough so that it brings more storage capacity for the next phase, it won't hurt you anymore in the next phase because of this enormous densification, let's say, effect Ronald has shown. The trick should be with the first phase already make enough room for the next phases. You see here how it works. In this case is an example with the top grid configuration. Waterside traffic is currently going out of the building and going forth and back from the quay wall. This is a transshipment terminal. Of course, we have only 2 interfacings for the landside traffic. When the terminal grows, you can decide whenever you want to enlarge it. In this case, that won't hurt you anymore because in the first blocks already so much storage capacity that is sufficient for all later steps. At the end, in this case study, 25% of the area has been retrofitted. And as a result, we've got 75% more storage capability. The point is, because with the 25% of retrofitted, you retrofit it with a system bringing 4 times more storage capacity and throughput capability than an RTG system. So I think Ronald and myself could talk hours and hours on that. We live that for, and we have a booth over there. If you're interested, please visit us. Thank you very much, and really I liked it to be here back. Thank you.
Okay, thank you very much. We did finish on schedule, so we have time for some questions. I'd like to invite everyone to come up and take a seat. This being shipping, we have I think 6 people and 4 chairs. Okay, before I can lead the discussion, but I think we should have the chance to have some questions from the floor before we do that. Does anyone have a question you'd like to pose?
My name is Wayne Brando from Brando Staff Training in Rotterdam, and I have a question for Box Bay.
Sure.
Is it possible to load dangerous cargo in Box Bay?
The answer is yes, but that depends on local rules in the country. So sometimes it's much easier to store it not in the building, but you can do. We have detection for fire and stuff like that. That solution is there, but so it depends. I make more designs. It depends a little bit on the local country rules.
Yeah. So, question to the Box Bay colleagues that as my presentation had those 3 factors: uptime, the success rate, and the productivity. How do you see the uptime in such high bay storage? In a way, the maintenance efforts needed compared to yard cranes like RTGs and RMGs. Thanks.
The uptime is higher than we have with other equipment. if you have visited, you don't have visited, but if you visited, you can see that it works very smoothly because we control the movement very accurately. So containers are not placed in the steel structure with big banks, so that goes very smoothly. That's always good for your equipment. And this is, of course, new for us. But to be honest, the company itself, where we work with, the Amova company, is building those devices already for more than 30 years. And the device what is bringing our containers in and out, that telescopic arm they use underneath of steel coils. The only thing what we do, we hang a container on it. So even if you look to the bearings and the design, it's all already there, up and running. So it is not a brand new developing for us. It is a combination of a company who has a good idea to store heavy stuff, and a combination of an user, we are Deeper World, and they bring that knowledge together. That's what we have done. And in my experience, I have done more terminals starting up. If I see how the progress that we made and how quickly we run up and a decent performance, but also a decent reliability, I can tell you some suppliers for us can learn something from that.
See, Ronald and myself, when we met first about 25 years ago, he was working for ECT and was working for Gottwald. We came with automated AGVs. This was something from the viewpoint of that time which was completely new. I would say it was not major, Ronald. Nothing was invented yet. So even Windows was not up in there. High bay warehouse systems, automated ones is not new. And also the high weight class with 40 tons and more is not new. That's working for 30 years. That what we did is to take it from the industry and implement it in the ports. Of course, there are some things what you might have overseen, but the grade of maturity is much bigger. And I think that should be, let's say, put also into your equation. How mature is a system what you are going to implement?
Thank you. Kinya Ichimura from Mitsui Yandest Machinery. So I have a question to Lisa. And then so it's a telecontrol instead of the remote control is a very interesting topic concept. But I think so it is very important to standardize of the communication of each machine. So is there any idea of standardization of the communication between telecommunication and the crane or truck or etc.? So any idea?
I'm not sure if I understand your question completely right, but you asked...
It is standardization of communication of each equipment.
Yeah. Well, I think that should be a big advantage if we get there. One of the other speakers also raised the issue about standardization, and it's not about standardization of the technique, but also the interface operators are having to operate. Because if you need to switch between equipment, then you don't want to make mistakes. You don't want to have if it's green on one interface and red on the other one, then it's not going well. So yeah, standardization should be a big benefit. And there are style guides, of course, for that. So maybe it's time for a style guide in the container industry. What do you think?
Yeah, I guess I can probably, just support what you said. Obviously, I guess for as long as there's standardized interface, that obviously is the key. You may have one or two different options in terms of technology solutions, how to solve the problem. I guess that's probably in terms of gaining efficiencies not so important across the industry. What you certainly would want to do is on one terminal, especially when it comes to remote control operation for a key crane, for an ASC or an RTG or whatever you have, you don't want to have then different technologies for the same sort of application. So I guess I would probably sort of distinguish those two things. So at least on one terminal, or if you run more terminals across the portfolio, it makes sense to have one technology solution, which then again sort of leads into please have a standardized interface. Yeah.
When I reflect that what I've seen from the early days of ECT until today, and that is 30 years passed by, I clearly see that we get more and more standardized, let's say, control rooms. So basically that we showed the box-based system, The control room of that POC, proof of concept plant there, looks not very much different, basically more or less identical to that what you are using at Terminal 3 or Terminal 4, isn't it?
Exactly. If you see, for instance, the truck interface we have, is exactly the same what we use in Al Jabal Ali. Okay. So the truck driver is no extra training now needed to go to the new location. But I agree, it's important that we standardize that. And of course, we only standardize in Jebel Ali. I don't want to say that this is the standard in the world, and that is what we are missing. Every location, I have to do this case again.
But a guy going into that control room would feel completely familiar, even that the system in the back, well, let's say in the front, which doing the job is looking completely different.
What about all the planning roles, the TOS and the yard planners? How does it work bringing Box Bay into the sort of Navis TOS environment you have in Jebel Ali?
I can answer that. If you see Box Bay in a standalone product, as an only Box Bay as a motor operandi, then you will have your yard model, your equipment control software is all part of the warehouse management system. But at the end, what you will see, what we notice now, it is by far more also integrated in a brownfield terminal. And there you will have an additional storage location, like that you have an empty yard and a laden yard with AUCs or RMGs. So you will have then a third one, that is the Box Bay. And we have now created an interface, an AP interface, what's already mentioned over there, what we first developed with our own in-house system, the Carcos from Deeper World, which is also available now. And it is a standard AP interface. We have done it in a way, if you are using TOS from Navis, you can also use it. Okay. But that's why I have set it up in that way. But in a terminal overall setup, it is a third location where you can store containers.
Okay. Murray and Dennis, if I can ask you something that relates to both your presentations. Murray, you talked about the complexity of automation and the challenges and pitfalls around project management. And Dennis, you talked about some of the limitations of terminal design and perhaps the potential of autonomous vehicles. While autonomous vehicles might help with some of the equipment issues of long travel of cranes and excessive resources that requires, does not bringing in autonomous vehicles add a whole another level of complexity at the software level in terms of fleet management and control of these vehicles when you have 150 or 200 autonomous vehicles running around a terminal? Is it something that the industry is sort of ready for, or is it we've got enough problems on our plate with the automated systems that we have at the moment?
Well, I think it's a very good question. The current systems, if you look at AGV terminals, they're centralized fleet management, centralized equipment control. So of course it's very attractive to have autonomous vehicles in the sense that you can have a mixed fleet and no separated traffic areas. So I wish I would say it would work indeed like that, but I don't think all of the maturity is there to run a full autonomous fleet. I think there's a lot of development being done, and I think maybe Dennis can elaborate on that the trucks itself can be autonomous, but how it integrates in a full fleet management, I have not yet seen bigger examples than very small pilot projects. And maybe it will come, because there's like the big Googles and the Volvos who are heavily investing. So I would not be surprised that we get a very disruptive moment in the industry where different players than the current industry that we see here will maybe enter from this side.
And probably adding to that, and thanks for mentioning Volvo in that sense. We're at an early stage of adoption, true. So we look at Lamjabang, for example. We look at in Vlissingen. There's now sort of live tests. We're not there that we had Singapore going fully autonomous trucks. The one advantage we have, and it's a great opportunity, which probably some of the established players may not like entirely. All the truck manufacturers, Volvo, MAN, all the other ones, with massively bigger R&D budgets than what we're used to in the industry, for them, mind you, deploying an autonomous truck in a container terminal is the most controlled environment where you can actually start. There's no baby strollers, there's no red traffic lights, there's no pedestrians looking at their phones whilst crossing the road. On a terminal, ideally, hopefully, compared to application on the open road. So what we do see is a lot of new market entrants that really like to use the container terminal as a very controlled test lab environment, just because the challenges in the container terminal are so much less compared to open road, that the technology is going to be there and deployable very, very soon. And then obviously it's a question of interfacing, obviously, but we will see a lot of push from the industry, backed with funding money, the likes of which we haven't seen in the industry. So I'm quite confident over the next 1.5, 2 years, we will certainly be there.
Well, I'll be interested to see if it endures. Don't forget, the industry is a good sandbox for the Volvos and the bigger companies of the world, but if you look at who's made port vehicles over the years, the market isn't big enough to excite Volvo to make a terminal tractor in the past.
Whilst I agree, here's the one thing. What's so special about what you need on a container terminal compared to what you will need on the open road? When it comes to technology, you might as well just develop the technology and then sort of, sell the components to whoever wants to have a specially designed sort of terminal tractor. What's key in making it work is the sensors, technology, and all the other components behind it. As I said, it's potentially a real threat to the established sort of incumbents in the market. And if you do start seeing a massive transition in the industry, if you look around parallel yard terminals in the world, and if you add up the horizontal transport units deployed there, it is not too small a market. So there is opportunity, in both ways, I would say.
Okay, thank you. Any more questions from the floor? We have one over here, please.
My name is Manuel Cabrera from Port Miami. I have a question, even though I know that we are far away from that type of system, Box Bay. I have a question very similar to the first one. Is that system prepared to handle refrigerated cargo? And if the answer is yes, what it will be the time frame of how long it will take to pull out a reefer in case of a failure detected by any monitoring system that you have, to take it out from the box, make the necessary repair, and put it back?
The reefer repair you will never do in the box bay itself, safety-wise. We are now having different designs how to solve it. One of them is with the robot arm. The stand is also over there, the C80. You can see them over there. And there we are working with that. There will be an automatic system to connect and disconnect. Then the only thing what is left over is, of course, the transportation time going out of the box bay and do it with a pallet or with another horizontal transport to bring it to your maintenance area. We will never do repair work in the yard. But what I said, we are working now with company RMC, which they are he is waving there in the background. You can see him in C80, the automatic connection and disconnecting system, which we will going to install in our box bay and will be tested out in the end of this year.
Okay. All right, thank you. I think we've come to the end of our time. We have to wrap up. If you give a round of applause for our panelists, that was a really great session. Thank you very much.